Hello, everybody. Good morning, good afternoon, or good evening, wherever you are. Today's podcast or live stream is from the AeroGear project, and we have with us Dimitra and Polina. They worked for Google Summer of Code this year on the AeroGear project, specifically there on the Unified Push Server, developing a proof of concept using Apache Kafka inside of the Unified Push Server as the central data hub for distributing messages. Polina and Dimitra have prepared a nice presentation with a little demo at the end, and they are now talking for the next minutes, explaining a little bit background of the project, as well, giving some insights on their experience with the Google Summer of Code project at large. So with that, I hand it over to Dimitra and Polina.
Hi everyone, welcome to our webinar. So we're going to be speaking about our Google Summer of Code experience from this summer. I'm Dimitra, currently living in Waterford, Ireland, doing my undergrad in applied computing. And I'll hand you over to Polina, who I worked with this project on.
Hello everyone, I'm Polina. I was born in Bulgaria and now I'm doing my master's degree in Germany. Like 4 months ago, we started working on the proof of concept of the Unified Push Server, and today we'll try to summarize and share our experience during this month. Let's share the presentation. And we can start. So a quick overview what this presentation will be about and how it will go on. Initially, we will share some personal thoughts or why did we apply for Google Summer of Code and why did we choose AeroGear as our organization. After that, we'll slowly move to the project itself. So we will try to describe what was the initial idea of the project, what have we did during the project, how we did it, and what still has to be done. So Dimitra, why did you apply for Google Summer of Code?
So why Google Summer of Code? Well, up till now, I haven't had much experience with open source. It was always something that I was interested in getting involved with, but I wasn't really sure how to get started, and this program seemed like the perfect remedy to that. I'm not sure if any of you remember Club Penguin, but it was like this multiplayer online game on Miniclip at the time, and I loved it. I was obsessed with it. We do have some people. So I remember a few years after, I was too old to be playing it, so I read this article that was talking about how Club Penguin dealt with all of this data, and they were explaining how they ingested a lot of data related to how penguins decorated their igloos, and it turns out there were a lot of trends related to certain items and times of the year and events happening. I think there was actually something related to memorials for 9/11. And I was really impressed. I thought that was so cool, and I've always been fascinated about it. So this is what led me to my interest in Kafka and Spark and technologies like that. And I think we've come a long way with big data and big data technologies like this. So a project that involved both Java and Kafka was really exciting to me. I really wanted to get involved with it. And another point I think is important is the idea of a strong community. So AeroGear has a really strong community, and it's important to have a support base when you want to get involved in something like open source software. If something goes wrong or you're just having a rough time, you need to be able to ask really stupid questions, and you need to know that they're not going to judge you and that it is okay to do that. So that's my motivation.
Okay, maybe I will repeat almost the same, but we have a lot of common interests, and maybe that's why we are such a great team. The first reason was that I haven't had any experience working for an open source project in an open source organization. So I was really curious to see how people distributed all over the world are working on one project, moving it forward, like how they distribute different tasks amongst each other, how they take decisions and things like that. When I read the first time description of the AeroGear Google Summer of Code project this year, the first thought in my mind was, okay, I'm perfect match for this project and I should be part of it. The project, the used technologies in the project were Java Enterprise Edition and Kafka, Apache Kafka. So having experience with Java and with others like big data technologies like Hadoop, Sparks, this project seems like a next level or extension to my knowledge. And lastly, like when you're part of a team, the most beneficial of being working with the others is how much you can learn from them. And I believe working with great developers make you better as well. Now we can move to explain about a little bit about our organization and the project we are working on the past 3 months. If we have to sum AeroGear in one sentence, it will be it brings mobile and enterprise together. So AeroGear organization provides different libraries and server-side components which will simplify your mobile development and the infrastructure setup across multiple platforms. As I mentioned, it provides a lot of modules, but what concerns us most is so-called push module. This is the module for sending push notifications to any device, regardless of the network or platform. I and Dimitra were working on a server-side component of this module called Unified Push Server. Unified Push Server is responsible for sending native push notifications to different operating systems like iOS, Android, and so on. So if you're searching for a product that will send a push notification message to your Android device, that's the right one. Initially, when we started, the idea was clear. We need to work on improving the capabilities of the server so we can make it more scalable, we can make it more reliable, and with better performance. As you can see here, this is the global architecture of the server we were working on. The most important functionality for us was the message sending. So we should make this process of sending push messages faster, regardless of the data, of the volume of the data our server is operating over. That's why we were concentrated on the sender module and the connected with it. The sender module was built on so-called Java message service or message queues. That's why Apache Kafka seemed like a good replacement of already existing message queues. But let us describe more about Apache Kafka and why did we choose it as a technology to base our project on. Dimitra?
Okay, so we just want to give a high-level overview of what Kafka is for anyone who hasn't encountered it before. You'll often see Kafka described as a distributed commit log. So that can be broken down, I think, into 3 main functionalities. Basically, Kafka lets you publish and subscribe to streams of records. In this case, it's pretty similar to your average messaging system. It's essentially just like a log of events, records, messages, 3 words to describe the same thing. The biggest difference with Kafka is that it is distributed in nature. So you can scale horizontally as opposed to throwing resources at hardware. You can simply add a new server and Kafka will handle replication really well for you. So it is also redundant by nature. thanks to what we call partitions and partition replication. So data loss is something that's not that you don't really have to worry about, and this is what makes Kafka such a great tool for production. Another thing is stream processing. So it lets you process streams of records in near real time, basically constant time in proportion to your network connection. So that's a really cool feature. This is just a nice diagram. So Kafka is usually run in a cluster of one or more servers. You can run it in a single node, but it wouldn't really make sense. You'd only really do that in development. In production, you'd really want to scale up as much as possible and have at least a couple of servers. So as you can see in the diagram, you have these producers, which are feeding data into Kafka, so from front-end services and applications. And then on the other end, we have lots of different consumers who are subscribing to the topics that the producers are publishing to. And then they're doing all sorts of things from the data. So you could hook it up to a data store. You could perform some processing on the data. You can really do whatever you want with it. A few cool features. So these are a few features I like about Kafka. I don't know if you'd share the same ideas, but one thing is that Kafka focuses on disk and read, run, write to disk. With most messaging systems, you'd have a copy of your data in memory and a copy in disk. But Kafka basically says, you know, these days operating systems are really good at caching, so why not use that to our advantage? Another feature is log compaction. So if you have loads of different records, let's say you're streaming millions of different records into Kafka, and a lot of these have the same key or the same value, you can compact those down into one record for disk storage. So if you're worried about saving space, that's a really good feature to have. Obviously, there will be a trade-off. You're going to sacrifice read and writes, but if you want to save space, it's a great feature. The way records are indexed with Kafka means that you can basically, you'll never lose data. So data is not ephemeral. You can replay it as many times as you want, thanks to multi-subscribers. So you can have multiple consumers reading off the same log, and they'll never, you know, clash into each other. So that actually turned out to be really useful. And lastly, big data ingest. So it's not much of a feature as much of it's more of a use case, but it is definitely worth talking about. So if you're streaming, as I said before, loads of data in, let's say you have 2 million records in 1 second, it's really likely that your services aren't going to keep up with that amount of data. So Kafka allows you, it acts as a data store. And initially for this proposal, we had talked about using HBase for our data, but we were talking about with Matthias the other day about potentially using Kafka instead, researching that as a possibility. So maybe for Google Summer of Code 2018, it's actually really great to have. And back to Pauline.
Okay, if we have to narrow it down to 3 reasons why did we choose Kafka, it will be partition lock, replications, and good storage system. So as Dimitra already said, each topic in Kafka has partition lock, which means that we do not need our topics to fit on a single machine. Topic can go beyond the size of a single machine. And if you think about it, if we base our push sending process on such kind of topics, we can increase and provide better scalability for our server. The topics are not only like partition, but they are also replicated. So for example, like you have a server that acts as a leader and multiple followers that replicates the leader. And you can have, for example, replication factor of n, which means that your topics and like your server is resilient to n-1 failures. This is the way how we bring reliability and no loss of data to our unified push server. And finally, Kafka can be seen as really good storage system. Usually you can think of it as kind of like big data distributed file system dedicated to like performance, to replication, partitions, and so on, which makes Kafka one of the best solutions for large-scale message processing nowadays. That's how we choose Kafka for our solution. But let's see what we did, and yeah, this is the time you can laugh at my graphic designer skills. One of the best thing I can say we implement and we achieved for the UPS was the removal of Java message services and its replacement with Apache Kafka. So here on this diagram, you can see like some initial phase of push sending process. We have our REST app API. You can request it and send push notification. Like you can send push message. All of these push messages are going to our initial topic. And yeah, you can see here that the topic is partitioned, so you can have multiple partitions of the topic. They can be placed on different Kafka brokers depending on your cluster. Also, you can have replication of them, so one partition can be replicated to different nodes in the cluster. That's how you can guarantee better performance. From our initial topic, we have all the data stream to our like stream processing and branching here. We're really proud that we managed to implement something with this cool new Kafka Stream API. And stream was used for branching all of these push messages to different topics. Each push message can be sent to like multiple devices, and we can have different devices with different operating systems. That's why we have like APNS push message topics, which are responsible for all of the push messages going to an iOS device, for example. Because it's a technical presentation and we really wanted to show some like code snippet, I will explain a little bit here about our branching and stream processing. So here we just like build our stream over our input topic with all the push messages. After that, we make some processing, extracting all the variants a push message will be sent to. Like a variant is a representation of mobile application. So we want all mobile applications installed on some devices that we will send our push message to. Because an application is developed for particularly for a specific operating system, for Android or for iOS, we have here our branching depending on the type of this variant. And here we push like our here our data or our push messages to different topics depending on the operating system. Here, something nice to say is that usually to a Kafka topic, you push key and value. And we use like custom serializers and deserializers for our key and values pushing to these topics. And yeah, you can see them described here. This is a continuation of the same process. So it's again push message sending. Let's say that here we have already distributed our push messages into different topics. We have like more complicated further processing, loading like device tokens, so the tokens of the device to which our push message will be sent. And we trigger a push sending process using some external like services as APNS and PSM. From this point onwards, delivering of the push message depends only on these external services. so that the mobile devices can receive it.
Okay, so another thing that we worked on at the beginning of Google Summer of Code. Okay, so at the beginning of Google Summer of Code, we started using vanilla Kafka consumers and producers, which we found to be quite verbose. It was okay at the beginning, but it wasn't very sustainable in the long term because we had properties files for every producer and consumer that we needed, and it turned out to be quite redundant. So we wanted to find a solution for this. And at the time, Matthias had started development on a context and dependency injection library for Kafka and Java. So we decided after a bit of research that that would probably be the best route for us to go with in terms of future implementation. The library at the beginning was quite small, but the good thing about it was that being our own, we were able to work on it. Like, for example, whenever we encountered a bug or a different use case that we hadn't thought of, we could cater for that almost immediately and then have that merged and working in very short periods of time. So that was a really good workflow. We weren't dependent on, third parties and external services and whatnot. The library is a lot more mature now. Matthias has been working on some cool features right now. I think he's in the current stages of stream support. That'll be really cool once it's merged, so watch out for that. In terms of what myself and Polina did, Polina worked on the library quite a lot in the initial phases of the project. So we encountered a few problems with the consumer injection. So she worked a lot on the library to improve like lifecycle dependencies and lifecycle management. I mainly focused on the library in the last half of GSoC. So I worked on implementing custom deserializers and serializers, as Polina mentioned before. We have a lot of custom objects that we wanted to push and pull from our topics. So unfortunately, objects like internal unified push message and push application weren't going to be supported out of the box by Apache Kafka. So we needed a solution for that. And under the hood now we have the library checking for object type with reflection. And then it will then provide serializers and deserializers for the key and values based on their types. So that was really useful for our needs. And right now we're doing all of this conversion to and from JSON, but maybe in the future we'll have support for something non-text based and a bit more lightweight. Feel free to get involved with that, throw some ideas. That'd be great. Another thing we worked on was push message metrics processing. So we have a lot of push notification delivery happening, and we have a lot of statistics and metrics related to that. So we wanted to record this information that, in order to process it at a later stage, right? So we came up with 3 main topics that we were interested in having a look at. The first one was for invalid tokens. So we have this invalid tokens topic, and we have a producer which is pushing to this topic, and then the consumer on the other end is pulling and deleting all of these invalid tokens out of the database. The second topic is for push message statistics. So we have, for example, we want to know about failures in a certain batch of push notifications or successes and total amounts of successful batches and stuff like that. So we push all of that information to a topic, and then we can do some processing on it at a later stage. And we essentially do the same as well, but with token statistics for Apple devices. APNS allows us to work at a more fine-grained level, at a token level. So we can do the exact same thing there and then process it at a later stage. And actually, we do have a demo that highlights this feature. I don't know if you can call it a feature, but we do have a demo for that. If you stick around until the end, we'll show you it.
Okay, something else, like we're really big fans of test-driven development and having some features implemented, JMS replaced, and different Kafka consumers and producers. We really want to set up more solid test environment so that we can test the real Kafka consumers and producers we are using in the UPS and their business logic. That's why we worked on setting up that's why we moved through this setup phase. We use the Debezium for having embedded Kafka cluster in our test environment. We use Mockito for providing mocks of different like components we are testing, and Aquilion for like packaging everything and deploy our jars to this test environment. I also want to mention that we are really proud of our blogs. We created them with the when the project started, and initially we thought, okay, it will be like a nice way to share our progress with developers in the community and with people who are interested. But after that, we started to believe that the sharing is caring. Right now, I think we are more open to share our experience with others, to write blog posts, because we saw it's a way how you can help people and how you can be helped. Yeah, we did a lot and we started some topics, but there is still room for improvement. So let us describe what we mean. Kafka security plays a really important role in moving our project forward. We started the research, we created some more concrete tasks, but we believe that like they can be done in the community. Because if we want to move our project more like in the production mode, we definitely should secure the connections to the Kafka cluster, the connections between the Kafka brokers, and so on. Another topic is testing, and Dimitra, maybe you want to talk about more about this?
Yeah, so ideally we would have liked to have more thorough testing in our own branch, and also spend a little time to improve the overall code coverage of the unified push server. We did start a bit of testing, as Polina mentioned before. We have a really nice test environment set up, and we've started testing some of the specific consumers and producers, but there is always space for improvement, and this would be something nice to look at in the future, just improve overall code coverage. And then lastly, here we have merge to master. So our final goal, as agreed upon with our mentors, was always just a working proof of concept as opposed to a production-ready product. And that also ties into what Polina was just talking about with Kafka security. There are a few things we have to think about before we're ready to merge to master, but it is worth spending some time on. It will be beneficial in the long run for everyone. You know, improving scalability and efficiency, lower profile and footprint. And then it also allows us to start factoring out certain logical parts of the push server. So speaking of which, actually we have the demo now, which illustrates this point. So if we start having specialized services, each one is focused on what it knows how to do best. And for example, with the push message processing, if we have external applications that are performing the processing, then we leave, you know, the real heavy stuff to the unified push server, which is what it knows how to do best, which is notification delivery. So that's one of the most important things about this, is being able to separate these logical functions. So we can move on to the demo. I have taken the liberty of recording it. I don't think a demo has ever gone right for me, so recording is more safe. I'll just do a quick voiceover on that. It is very simple, but it kind of illustrates this point nicely. So I'll try and open the YouTube video. Tell me if you can see it. If you can't, we'll make a plan. Can you see that?
Yeah, we can see.
Yeah.
Okay. So I'll just voice over. Here I'm just starting the Wildfly server for the unified push server. And then while that's going on, I'll just talk through some of the code. So this is the class for processing the APNS token metrics, which I was talking about before. This starts on application startup, so we're just initializing everything all the streams configuration. And then once that's done, we can start building our stream from the token metrics input topic. So we're using the streams API for that. And then we can go through and start performing the actual processing that we want to do, which is counting failures, counting successes, and counting total tokens per job. So let me just pause quickly. This is basically just using the group by key function. So we're looking at the value when it equals success or the value when it's failure. And then we can basically look at the count per each one and then stream that out to its respective topic. So this is for APNS tokens. And then the other class that we have in this project is for push message metrics as well. It essentially does the exact same thing. So I won't go into this one as in depth, but you can view the code after if you're interested. Exact same thing, success messages per job, failed messages per job, and total messages per job. And we just want to count those from the topic that we're pushing to earlier. This is the consumer class. So we have 3 different consumers that are reading off of the streams topics that we just streamed to once the processing is done. So we have consumers for reading the successes, the failures. Oh, I'm ahead of myself here. Yeah, success tokens per job. So we're reading from that topic. That's just what I'm showing there. And then we'll just log it to console. We'll just do a simple log to console to show you what that looks like once the streaming has happened. Lastly, this is just the Kafka cluster configuration. It's really simple. You basically just need the @Kafka config annotation and then the link to the address of your Kafka broker. And you also have to do the same for streams because we don't have stream support with the Kafka CDI right now. But it's really simple, as you can see. So here we're in the application now. This is the application I was just talking about. It is a Wildfly Swarm application. So basically what I did before this command that I just typed was a Maven clean install. And what that's going to do is it's going to build a fat jar with the server as well as the application and all of its dependencies. So you don't need to be deploying to an external, so you don't need to be deploying your WAR files to a server, and it's just really easy. And then I have all of the Kafka logging here. It's really verbose, but interesting to see, I guess. This is just the stream classes starting up. And here's my push notification. I'm just going to call the REST sender endpoint with a simple hello world application to my Android device. Oh yeah, I'm going to actually send a couple just to illustrate what it looks like. Send a couple of notifications to that device. This is the Wildfly server. I'm just showing you here that it's delivering to the Android variant. It's going through our streams notification delivery that Polina was talking about, and then getting sent, handled by the FCM sender network for Android. So I think we're going to go to the application now, and this is the output. So this is what we're logging from the consumers. It's basically just showing you the 5 different messages. We have a different message ID for all of them because I only sent one message, and that's the total amount 1. So just to show you that these 5 different messages have 5 different IDs, and that's really simple for the push message delivery, but it illustrates the point, I guess. Yeah, now we move on to Apple. So this is just sending a notification to my Apple device. Actually, I have 2 devices on there. So we're just sending a hello Apple notification. Yeah, and then I believe we'll go to the application now. So it's just waiting for the streaming to happen. It's received the Wildfly, so the server, that unified push server has received the things and it's sending it off. But here we're streaming the results. So total messages for the job ID is the 2. And then failures, we have 1 failure and 1 success. And then as you can see, the job ID is the same for all of those. So maybe what you'd want to do is group that data by the job ID, and then maybe display it as a graph or something, hook it up to Grafana, or do whatever you want with it. But you can go, you can go a lot further with that. But just to show you, the possibilities of having that as a separate process, you can do some really cool stuff with it. Any questions, be sure to ask me at the end. And finally, just a quick wrap up. So our project was Mainly, we were looking at extending the capability of what the unified push server could do, how we could improve scalability, improve reliability, improve performance. And we chose Apache Kafka to do this. It's a really great distributed big data messaging system. We had a lot of fun with it, and I would highly recommend playing around with it if you haven't. It's actually quite easy to get going with, so I would recommend that. Then we also wanted to start moving the push message sending process to Apache Kafka using the Kafka streams, as Polina showed you before. And that allows us to handle huge amounts of messages very quickly without loss of data. And it's actually really resilient to failures and to stuff like that. So I'll hand you over to Polina now.
Maybe before we finish, I want to say that we built a solid Apache Kafka presence in UPS server, which can be easily extended and continue to be improved in the community. And that's the way we see the future of the UPS server. Thanks for listening. We're really thankful that we were part of such a supporting, and we are part of such a supporting community. We really want to thank to our mentors. They were amazing. They helped us a lot. Matthias, Massimo, and Lee. I forgot to mention that you can find the links to our blogs on this slide, so feel free to reach us out and to leave us feedback. Thanks again.
Thanks to everyone, and thanks Polina as well for being a great teammate to work with.
All right, awesome. Thank you very much for this nice presentation. It was great. Also, I really liked the demo where you were running a completely separate project, reading data from the stream and then processing it on its own interest. Very, very nice demo. I see there's one question from Lee. He's asking, what's next for you? Would you like to contribute towards within AeroGear after now gaining the knowledge and the experience of Google Summer of Code? That's an interesting question.
Yeah, very interesting. I can go if you want, Polina. I can start. I think, yes, of course. Just because Google Summer of Code is over, you don't stop working on the project. I think you kind of grow fond of it, so you want to see it advance in a certain, in a certain sense. So I definitely will be trying my best to work when I'm back at college. As I said before, the community is really great, and it makes you want to carry on and help contribute towards the project.
Yeah, maybe I will repeat the same. If I have time, taking into account the university and my master's degree, master thesis that I hope I will finish soon. I really want to continue to contribute because I gain a lot from, and I learn a lot from everyone. It's so nice to be part of such strong and supportive community.
Awesome. I don't see any other questions on the chat here, but I do have a generic question. So now we saw all the technical stuff, the technical materials, and you explained very well all the challenges that you were going through, but I'm more interested at a general level, the experience with open source in general and the Google Summer of Code project. So how are your feelings about the the overall Google Summer of Code project in general? Would you like to share some of your feelings there or experiences that you maybe ran into?
Yes, I said I was really curious to be part of such open source project, and you can learn a lot from the developers. Of course, you will improve your programming skills and your problem solving skills. But the most important part for me and the most beneficial was to be more open, to search for help and to receive such help from the others. So yeah, that's why I will take as a point. Another thing that I can say make me better or improve my skills is I learned to be more proactive and to take the initiative. I remember when Matthias told us that he's going to a vacation, we were really like, what we are going to do now? How we were going, like how we managed to do the project, to manage the project by ourselves. And that was the moment and the turning point for us that we said, okay, this is our project. Like we applied, we wrote this proposal, we are really motivated. We have our like final goal. We know like at the end what we want, so let's do it. And maybe one advice to all students, I think that I made a mistake not taking like the best of the bonding period. I can say that think of a bonding period as part of the program, chat with the community, like ask questions. Maybe they are stupid, but you will not be judged anyway. So be more open and take, like, do your best and take the most you can. I think that's.
Yeah, I think that's a really good answer.
Thank you, Polina.
Yeah, the community is greater than code. I actually remember before GSoC started, I was up, I think Polina as well, I was absolutely terrified to share anything on the mailing list or to ask questions. And Matthias told me community, he told me, I think it's the Apache motto or something like that, but he said community is greater than code. And I was like, what does that mean? Like, I'm really good at, like, I really like code, but I'm not so much social butterfly. But that is something that we had to learn, that like community is really important. Like you can't expect to do everything on your own, you know, you're part of a team. So I think we both learned that lesson, and sharing is actually really cool. Doing everything in the open, it's really important, obviously, in an open source project. It sounds stupid to say, but it's true. It sounds obvious, but it is really true, and it's something we had to learn. And I agree with Polina's answer, like everything she said, I feel the exact same. I think it's just dealing with, like, you're always going to have ups and downs in a project, right? It's dealing with those in the best possible way. So instead of seeing it as an obstacle, like, sounds cheesy, but instead of getting down about it, we had to kind of see it as a learning opportunity. And at the end, when you look back, you do realize how much you've learned and how much that has helped you dealing with the ups and downs.
I think your mentors are there, like, to help you if you have problems, or to give you some directions, like you can look at this or you can try this, but like it's students' project, and like they should move the project forward. They should take the initiative.
Yeah.
All right, perfect. It's great to feel the enthusiasm, all the euphoric thoughts. It's really good reflection for us as well as a project to over and over years apply and apply. Yeah, thank you very much for sharing all of your insights, knowledge, and the nice presentation with this nice little demo. I guess I will share on our AeroGear mailing list the links of the recorded Hangout on Air. I will also put together the link to the slide deck, as well the video from the demo, and I guess the source code for that standalone Wildfly Swarm application. If you don't have anything else, I guess we are pretty much done here. All right, then I would really again like to thank you for the time and putting this together. I hope everybody on the stream was also really enjoying it and getting something out of it. And with that, I would like to conclude and wish everybody a nice Friday evening and a great weekend, and see you online on IRC. Bye-bye.
Thank you. Bye.